like a kind of closed classes and closed instances. And they cannot be modified. This is the first thing that I would do. And then I would implement the attribute access and items access to avoid modifications, maybe. Okay. So, yeah, as I said, this exercise is longer than the previous one, and it's more complex. There are two kinds of things to solve. In one case, there is a problem of all style classes inheritance. You have to solve it. This is quite easy. But then you have to implement two, let's say, amazing classes. You have to implement, do you remember, well, I have implemented in the exercise there is a custom ordered dig. Do you know what is ordered dig? In collections, you have this data type, which is a dictionary which remembers the order of keys that you added to this dictionary. So what I want you to do is to implement a slicing of this custom ordered dig. And I also want you to implement addition and subtraction. The thing is that, well, it's interesting to implement it. It's harder than the previous exercise, of course. And the third exercise, you have to modify the attribute dig that I have shown you here. And you have to modify its behavior. It's something quite specific. So you just have to make it access the keys only if they exist. And otherwise, so you remember we implemented attribute access. So you have to limit the attribute access to access the keys only when they already exist as a key. Otherwise, you have to behave like if it was a standard attribute of your class. Okay? So on one hand, you have to change the custom ordered dig. You have to solve the inheritance problem of custom option parser. And you have to modify the attribute dig to have this more specific behavior. Okay? You have the exercises folder, and inside the exercises folder there is an exercise 2 folder, and there you have 3 files. The exercise that you have to modify, the tests that you have to run with nose test, and you have also a solution. You can check the solution if you want to compare with your solution, or if you really get stuck, whatever. At the end, we will compare the solutions and we will discuss about it, and we'll find interesting things to discuss with the solution, because most probably you will implement some things different. The idea is that you start working with it and start customizing for first time your objects, or in this case my objects, but start dealing with customization and see possible pitfalls and this kind of things. Okay, so let's say that I'm going to leave maybe 20 or 30 minutes. In 20 minutes, I will ask you how are you doing, okay, and let's see how many people has finished or where are you, okay, and then we will see if we leave more or less time and so on. And if you have any questions, I'm here. For the new people that came at the break, I have a memory pen with the code. Otherwise, in the page of the Europython website, if you go to the talk, you will find a link to GitHub where you can download the code. And you only need Python 2.7 and nose test, okay? So let's start. Okay, it has been 10 minutes. How are you doing? How many have finished the first one? The thing of the new style, old style inheritance? Okay, good. Yeah, that's easy. And the second one? How many of you have finished? Nobody. Good, good. Then it's difficult. Good. So here I had two questions. I think it's important to share with you. One question was, in the attribute dict customization, how I have to handle the attribute. So the thing is, okay, I check and it's not a key in the dictionary. And then how I handle it. What should I do? The thing is that you shouldn't handle it. It's not your responsibility. So call your superclass and let your superclass handle the attribute as a standard attribute access, instead of doing it yourself, and let your superclass do it. Or that's the way I think that you should focus the problem. Because if you try to process the attribute as a real attribute and do it everything yourself, it's not what you wanted to do in your subclass, and it's something that is already implemented somewhere. So forget about how to implement it yourself and delegate to somebody that most probably knows how to do it. And the other question was regarding the addition and subtraction of dictionaries. And the thing is, and why should you return a new dictionary, or should you update the left side argument of the addition or the subtraction? So in this case, I have I have chosen the first one, to return a new object, because maybe it's the most coherent thing or the most coherent behavior compared with other standard types. When you sum two numbers, you get a new number. When you sum two floats, you get a new float. When you sum two strings, you get a new string. You could think, okay, but this behavior is normal because they are immutable and they cannot be changed. Yeah, but when you sum two lists, it also returns a new list. So that's why I'm returning a list. Would it be possible to customize the addition and subtraction to modify directly the object? Yes, you can do it. It's up to you. But bear in mind that then maybe this operation is not so coherent with the rest of standard types. And maybe if somebody has to use your library, your classes, and is not aware that the addition modifies the object, it could be problematic. So you have to understand both points of views. I would love to have an operand and say, okay, I want to update the left side dictionary with this other dictionary. Instead of calling the update method, I would like to have an operation. It would be lovely because I would save typing a bit. But it's not so coherent, maybe. So, well, this is the solution I said that we could find solving this problem. Sometimes it's difficult to implement some behavior that it's designed maybe for other kinds of types. So you see the addition of twins, and you understand perfectly how works the addition of twins. But when you are summing two dictionaries, well, it's different, or maybe other more complex classes that you will have when you are implementing your business logic at home or wherever. So I leave 10 more minutes and I check again, how are you doing? Another question here was the arguments of working with dictionaries. Bear in mind that it's possible to construct a dictionary this way. Great. Ah, sorry. Ooh. Ah. Yeah, it's better if I put it this way. Okay, so I'm providing a list of tuples, or I could provide a tuple of tuples. And the internal tuples have length 2, and dictionary will interpret it as key, value, okay? Key A, value 1, key B, value 2. Okay, and you can use also this format when you call the update method of the dic class, or when you use a constructor and so on. So in the test, I'm using this format in some places. And I also use zip, which zip takes two sequences, 2 or more sequences, and it returns pairs. So with zip, I can construct this input here in a more easier way. Okay, it's a built-in function. So, how is it going? Let's raise your hand if you have finished, besides the first one, besides the first exercise, also one of the others too. One hand, oops. 2, okay, 2, 3, okay. The thing is that we're running out of time. We have taken lots of time with explanation, maybe too much, and we should try to move on, okay? So, well, if you want, you can continue with exercise, or let's vote maybe. Or we continue with exercise. Either we continue with exercise and I will have to shorten the other explanations of the rest of the training, or we leave the exercise here, we discuss the solution, and then I will not shorten so much the rest of the training. So who wants to end the exercise now? Let's vote. Raise your hand. Okay. I think that we will finish the exercise now. Good. Okay, so let's go ahead with the solutions. So here the inheritance was wrong, and which was the solution? Volunteer? Yeah, inherit from object. That's it. Pretty easy. If you inherit from another style class, just inherit from object, and you will be able to customize all these kind of things that we have done right now. Okay. If you don't do it, you won't be able to do it, and you will have problems, and you will find strange errors. Sometimes sometimes it's a bit difficult to realize that you are really inheriting from an old style class. Maybe the easiest thing is to use the type, as I did at the beginning of this module, okay, and then you can check it. Yeah, you just type, and then it looks coherent compared with class. Otherwise, it wouldn't. And if you try to inherit and do things, you would get strange errors. So next example, you have to implement slicing, addition, and subtraction. And this is the right implementation. Look, we discussed about it previously, and this is how you have to do. You are going to receive a slice object. This is quite tricky. As I said, initially we had underscore get slice, but then it was removed, and you have to implement it also in get item. So your get item method is able to deal with indexes, like accessing a certain position inside a list or a tuple. Is able to deal with keys, like accessing a dictionary, and it's able to deal with slicing. And in this case, we're implementing something maybe a bit strange, because it's like you are doing a slicing of a dictionary, which is strange, but it's up to you. You have to customize your objects as you want, and as you feel that you are able to do it. As I said, bear in mind that maybe later other people have to use your classes, your instances, and have to deal with them. So do things in a coherent way, and don't do kind of black magic or this kind of strange stuff, okay? In this case, I return a new instance. Remember, slicing always returns a new object. And I just use slicing in the items. So if I take a dictionary, for instance, this dictionary I created a while ago. Oh, sorry. If you call to the items method, you get this list. So I'm just creating a dictionary, actually a new custom ordered dict, providing this list but applying the slicing inside it. Okay, questions? Understood? Okay. So addition and subtraction. The thing is that we discussed it's what we discussed a few moments ago, that it's up to you if you want to update your own object or you want to create a new object and update it. It's up to you, and you have to decide the way you apply it. In this case, I created a new one because I feel that it's more coherent with the addition of lists, numbers, tuples, or whatever. Okay, and the same with the subtraction. But in the subtraction, I don't have the update method, so I have to do it in a more tricky way. Well, I have to implement it. This is called list comprehension. So I'm not pretty sure if you are familiar with these syntaxes. It's like a kind of for loop, but expressed in a different way.
But here you don't need it because you're not using its result.
Yeah, I'm not using its result, but I'm calling it this way. Yeah, maybe the thing is that, well, I should have put a more understandable implementation. Sorry for this. Yeah, there was a question there, I think.
Yes. I thought to implement the sub like minus between sets. That
Like
all the elements that are in the first that are not in the second are in the minus, and in the result of sub. If I have two sets and I S1 and S2 and
This is what I do here.
minus S2, I have a new set with those elements.
Yeah. You mean to remove the intersection of the set, right?
Remove the
Yeah, the intersection.
yes.
With intersection, you get the elements in both, and then you remove from the first set the elements of the intersection. Yeah, this is what it does here. But maybe,
Yes.
yeah. The thing is also that I put here known, so in this case it doesn't give an error if I try to subtract a key which was not present in the first dictionary. Okay, so we try it and it works fine. We can sum two slices of the same dictionary and it gives almost the same dictionary without the index remaining, which is the index 3, okay? It works. And now the implementation of the attribute dict. As I said, the thing here is that I rely on the ancestor, on the superclass, to perform the management of attributes. Okay? Yeah.
Specific question. Wouldn't it be better instead of calling dict and the model to call supper?
We are going to see supper in the next module. That's why, yeah. He asked something because it's an advantage. Yeah, he knows super, which is the thing that we are going to see in the next module. So yeah, actually, it works fine. You can check the solution later and see it. And if you have more doubts, I'll be here the whole week, so you can ask me. And the thing, as it was asked, is that there is a way to implement it still better. And let's go through it, okay? Links to all the documentation, all the official documentation for all this stuff, okay? And let's move ahead. We're gonna see method resolution order, supper, and get ATTR, okay? Let's see how it works. Okay, let's imagine that we implement a verbose dictionary. In this case, the only thing that we are doing is printing each time an attribute is accessed, an item is accessed or modified, okay? Check this, we have get attribute and get ATTR. We have seen get ATTR. This is called only when the attribute is not found, okay? And get attribute is called always. So if you want to intercept the attribute access always, you can use get attribute instead of get ATTR. Okay, you have both, and it's up to you. So, pretty stupid dictionary. It just prints I access the key the key C, and I try to change its value to 3. So my class prints this formation. I try to access attributes and it prints again. I try to access an attribute and it's captured by get attribute, so on. So pretty simple, okay? It just prints what I'm trying to access inside attribute, either attribute or class, or item. So the thing is, what happens if we want to merge this behavior with our previous attribute dict? We implemented a dictionary with attribute access, and we have a dictionary which prints all the accesses that we are doing. And we want both. How we should solve it? Somebody knows the solution? Anybody? Okay, there are different options. Yeah, this was the implementation of the attribute dict, the previous attribute dict. Option 1, multiple inheritance, right? It's here. It's easy to use it. Just write here all the ancestors classes, and it should work. Let's try it. Oops. something happens. Look. I say x equals 7, and x does not appear here. Okay, so it's not working at all. It prints all the excesses, but it's not attribute dig. It's not being used, or the attribute dig behavior is not being used. We do the other way. We use attribute dig, and we use verbose dig, and we change the order of the ancestors. What happens is that now attribute dig works better. Actually, we have changed, we changed A, and here A is changed. However, if you look at it carefully, you will see how some accesses are not logged, okay? So verbose dig is not behaving as expected. The first conclusion is that the order of the ancestors, the order of the superclasses matters. And it's important to understand that it matters. So either you define one and the other, or the other way, your code could behave in different ways. But we can improve it, okay? We can enhance this behavior. Other options to implement our dictionary with both merge behaviors could be to implement a new class from scratch, implement a class, implement both behaviors in absolutely new class. Well, you have to implement everything from scratch. It's not, you should try to reuse, so you're not reusing, okay? Don't repeat yourself, remember. Another option, change verbose dig to inherit from attribute dig. In this case, we have to change the call, the code, to change the calls. Look at our implementation of verbose dig, and you will see how always we are calling the superclass directly. So if we change the dig, we should come here and say, okay, now you will inherit from attr dig. And here you are not going to call dig. You have to call attr dig. Otherwise you would skip attr dig. Okay, understood? Yeah, question.
But is that a formal parameter? I mean, why should it care if it's called dig or if it's...
Because if you call directly dig, you are skipping attribute dig, and then you would then, it won't execute, so you wouldn't have its behavior, actually.
I guess what I'm asking is, in this case, is dig a reserved name?
Yeah, dig is a reserved name. It's the name of the superclass. So you are calling directly the superclass here. You inherit from the superclass, and here you call the superclass directly. And you say, I want to execute this method defined in this ancestor. So you should change it and put attribute dig here and attribute dig in all the places. So you have to change the code again, and we don't want to change the code. We want to reuse everything. We have other options, but none of them are right, because the problem here is that the initial implementation of our classes is wrong. We should do it in a better way. The solution is super and cooperative methods. So according to the documentation, super returns a proxy object that delegates method calls to a parent or sibling class of type. Type is specified here in your call to super. Typically, you call super with your current class and self, the method that you want to execute, and your arguments. Typically, the same argument that you received. Let me remind that it only works for new style classes, and the maybe good news is that in Python 3, both arguments are optional, because by default, it takes the current class and it takes self. So most probably you read this and you think, I have not understood anything. What's this? And let's see an example and you will understand it better, okay? Look, now we re-implement our verbose dig. We still inherit from dig, but in this case, we call super. So as the documentation said, is a proxy which at the end what it will make is that this call will be executed in one of your ancestors. In which ancestor, it doesn't matter. You don't have to worry which ancestor you have to go to call to find this method. Super will take the list of ancestors of self, will go one after the other looking for get attribute __ get attribute method and will call it for you. So you don't have to worry where I have to call this exact method in which exact ancestor. Super will do it.
How is this different than calling get directly?
In this case, it's the same because you are inheriting directly from Dick. In this case, it's the same. At the end, it will call Dick. At the end, it calls Dick in this example, in this exact example. But in our problem, trying to merge both classes, it will help us, and we will see how. Okay, let's continue a bit, and then we will see it. The thing is that you delegate to Super the decision of which superclass is going to be used to execute this method. So you don't have to be aware of where exactly it's defined or where I'm going to find it or which name should I write here and what happens if I change the ancestor and whatever. Let's see a bit more examples. And so we also changed ATTR Dick and we also use Super. Again, in this case, it would call Dick directly, okay? So I repeat, the only thing that they have changed is that instead of calling that Dick directly, I call Super. I provide the current class and I provide self. And now I implement this new class. Look at the signature of this new class. It's quite easy, quite simple. I inherit from both, and that's all. But both now use Super instead of calling directly to superclass. The thing is that now, when verbose Dick calls Super, it won't go to call its ancestor. It will go to call the ancestor, the next ancestor of this new class, because now you are working with a different class. Let's try it. We will see that it works, and then we will see carefully and in detail how it works. So I implement my verbose, I instantiate my verbose attribute Dick, my new class. I try to set an item, and it works fine. Okay, this was easy. I try to set an item, I try to set an attribute, and it works fine. And now I try to set an attribute which is already defined as key. Remember the behavior of our attribute Dick customize? If the key already exists, we modify the key. Otherwise, we modify the attribute. So what's happening? Set ATTR is called, and then set ATTR calls set item. It works. We have both behaviors here. It's magic. Thanks to Super, just thanks to Super. Why? Because with Super, you don't have to care which ancestor you are calling. And in this case, the ancestors list that you have to check is the ancestors list of the real class that you are using. Let's see a much more easy example, much easier example, okay? We try to retrieve an attribute, and it also works. We call get attribute. Remember, this one is called always. We access an attribute. This one is called when the attribute is not found. And we had implemented this one to try to look for an item inside the dictionary, and we retrieve the item. So everything is working as we wanted. We could try another option. We could change verbose Dick to inherit from ATTR-DIC. And thanks to using Super, we only have to change this line of code. Only this line, nothing else. And the rest will continue working. And again, our examples will continue working, all of them. Let's see how it works in detail. So in my own words, I would say that Super is an implicit ancestors method invocation mechanism. So you don't have to worry which superclass is going to be used. Super will do it for you. Guidos called it cooperative super call pattern or call next method pattern. And you have all the description here. Maybe it's a bit difficult, so yeah, I said that it was an introductory training, and maybe this part is a bit more difficult, but let's see in detail. Okay, let's see another example, and you will understand for sure this example. We have a class called A, and this class has a method. The method will print the type of self, and we will say that it's in A, okay? We have another class inheriting from A. It does the same, but it calls Super. So it calls the same method in the ancestor. Right? So if I create an instance of B, and I do b.method, we are calling this method, right? This method is executed. This print statement is executed. So it prints the type of self, and it prints this text, and it calls Super. And Super looks for any ancestor which has this method defined and calls it. Right? To here it's quite easy. Any questions? Yeah, question. If two superclasses have the same method,
methods with the same.
we will see this example. We will see this example. Yeah, this is the good example of Super. Okay, so up to here it's easy. Let's see this case. We have another class which is also a subclass of A, and does exactly the same than B. Prints something and calls Super. And at the end, we have a subclass of both. We have D, subclass of B and C. And both have the method defined as well as A as well as D. So all the classes have method defined, and method does the same in all the classes. Print a line and call Super. So we have this diagram, okay? And we execute it. And this is what happens. We call D. We call D.method. And D.method is called. And then it calls Super. Looking at the diagram, which is the next ancestor of D? It's B. And the method in B is called. Okay, and the method in B calls Super again. So it has to call the next ancestor. Which is the next ancestor? Who said A? But the thing here is that you are not, well, the question was tricky. The next ancestor of who? Who are you? Who is self? It's an instance of D. And who is the next ancestor of D? C. So Super will call C because it's the next ancestor of D. That's why I'm printing always self.type, to let you see how self is always an instance of D. And you have to look at the ancestors of D, not at the ancestor of B or at the ancestor of C. Otherwise, in most of the cases, C methods would never be called because it would go straight from B to A directly. And you don't want this because that's why you are inheriting from both classes. You want both behaviors.
So why don't you have two A's?
If you have two A's, what do you mean?
Why don't you have two A's at the end? Because both B and C.
You have two A's. Actually, you have two A's here. Both B and C inherit from A, so you have this schema.
But why don't you have it on the output?
Yeah, I have A, but at the end.
Only one.
Yeah, but it's the same in both. So both inherit from the same. It's not a tree. In this case, it's not a tree. If you had A1 and A2, you would have then A1, A1, and A2. So if
Yeah, see what we mean.
and it was C, right?
I see this where both B and C inherits from A, and then you execute a method in both of them.
But then
I'm expecting the same method to be executed.
only once. Because look at this. You call the method in D and call supper. Supper calls the next ancestor. The next ancestor is B. It calls again supper, and the next ancestor, according to D, is C. Okay? So you call C. And then it calls supper again. What's the next ancestor in the list? So the next ancestor is only A. There is only one A. There is no two A's. So now the question that you should be doing here is, and how I know exactly the list of ancestors? Well, you can do method resolution order. Ooh. And here you have the list. There are no repetitions on the list. Well, if you had a really complex schema, something like being inheriting from A and I don't know, but at the end you will have only one ancestor, so each class only once, okay? And this is what super uses. Super takes self and takes a method resolution order. Okay? So the key here is to understand that the next ancestor, the method resolution order, is always taken according to the current class, according to self, which in our example is D, always D, always D. Okay? Otherwise, C methods wouldn't be executed most of the times. So let's implement a different example. A2, C2, B2, but check it. C inherits from A, but B inherits from C. So we have this implementation. The implementation of method is always the same. Print something and call supper, okay? So in this case, we have a linear inheritance schema instead of a diamond, but the method resolution order, it's exactly the same. In this case, it's more obvious because it's completely linear, but it's the same method resolution order. That's why if you look carefully at the two solutions that I propose with verbose dig and attribute dig, I implemented both. Either multiple inheritance or either change one instance to inherit from the other. But using supper, you only change the first line of declaration of the class and nothing else. You only say, okay, now your ancestor is this one, and nothing else is changed, okay? So if you execute method in this D2, the result is exactly the same because the method resolution order is exactly the same. Here you have. This is what really matters, and this is what you have to understand. So there is an amazing discussion on whether multiple inheritance is the evil and you should avoid it, or you should take it, or I'm not going into this discussion, but You have to be careful, and you have to understand this thing. You have to understand exactly how it works, what's happening. Okay, you have to understand that there is a method resolution order, and that always the method resolution order is taken according to self, according to the subclass. And this big piece of text explains how it works. Let's see. As I said, the method resolution order is taken always from self. In D, in this method, so the first call to d.method, we call supper. And we will find and call B, because we take this method resolution order. We know that we are in D, so we have to take the next one from B, and the next one, sorry, from D, and the next one is B. Supper goes here, takes B declaration, and says, okay, it has method defined, I call it. If method was not defined, it will continue looking in the next classes. But method is defined, so it calls it. And method in B calls again supper. Okay, calls again supper. And what happens? That we have to take again the method resolution order with respect to an instance of D. So the method resolution order, as we have seen, is D, B, C, A. But now we are calling it from B. That's why you provide here B, to let supper know exactly from where it's being called. This is to let supper know in which index in this tuple it has to start looking for another ancestor. And as we are now in B, the next one is C. And the method in C is called. And the same happens, it calls supper. And it goes to A and executes method in A, and it's not calling supper, so all the calls end. And that's it. It's the first time it's a bit difficult to understand. If you want, try to play a bit with this diamond schema, or try it a bit more complex, but at the end, in most of the cases, you don't have diamond schemas. But maybe you have a linear schema, a linear inheritance schema, and the thing is that with supper, you don't have to worry which is your ancestor. And in the future, you can change your ancestor and inherit from another class, and you don't have to worry again to change all the places that you were calling to the ancestor. This is why this is the thing with supper. Okay. As we have seen, this process ensures that all ancestors of a class are always inspected and are always executed. Otherwise, in our diamond schema, C methods wouldn't be called. The same happens with get attribute or with attribute access, standard attribute access. It's exactly the same. Now we have this schema, and we have an attribute defined in two places. When I called d.3.class attribute, which value will be returned? When I call d3.class attribute, which value I'm going to retrieve? C3, yeah. This is the same. Attribute retrieval also takes the method resolution order and goes to all the superclasses looking for an attribute or a method. It's the same, because as I said, methods are attributes, but later you execute them. And here you have. So you would say, why they implemented this thing? Well, the thing is that with the introduction of the new style classes, absolutely everything inherits from object. So suddenly, in all the style, you had this diagram, and with the introduction of object, you started having this diagram. And they realized that the old implementation of the method resolution order was going to ignore C, and it shouldn't happen. That's why all this stuff was introduced. Okay? So I have even more examples of how to exploit it using verbose dig and attribute dig. Actually, this example tries to exploit mixins, which is we implement both without inheriting from dig, and at the end, we implement a class inheriting from verbose, attribute, and dig. And it works exactly the same way that it did the first time. Because its method resolution order is exactly the same. So now I have an exercise. The thing is that we have run out of time. There is still another module. This is shorter, but I think it's time again to vote. If I have no problem to stay here a bit more. In this new module, there are no exercises, but I explain what's __ new and what's a meta class. So the thing is, if you want, you can stay. We have a bit more time, right?
I think, well, how much more time?
I think that maybe 10 minutes. I hope.
10 minutes is okay.
I hope. It depends on the dobs. So
Okay.
we will skip the exercise. You can do it at home or when you want. And if you really want, if you want, you can leave. I'm sorry, but we have taken a lot of time with the previous explanations and all the dobs and all these kind of things. So it's up to you. If you want to stay, I will stay 10 minutes more, and let's see what's new. Okay? So let's go straight to the last one. Well, new stuff. __ new. Anybody knows what's __ new? It's a real constructor of the instance. It's a method in charge of really creating a new object. Because look here, init receives selves as an argument. So init is receiving as the first argument, it's receiving an already created, an already existing instance, an already existing object. Because new has created this object. But most of the times you don't need new. That's why most probably most of you have never used new. Because most of the times you don't need it. But it exists and it's here. And you can customize how your instance is created, but really created, not how it's initialized. Here you initialize the instance, you fill its content. You take its attributes and you put value to the attributes and these kind of things. But here is where you really create the object. So in this case, I'm just printing what it has to do, and as we have seen, I'm calling supper. Get used to call supper as much as possible, because this way it makes you easier to inherit, and it makes you easier to later extend your code. So I'm really delegating the creation to my superclass, and I don't have to worry on who is my superclass, okay? So I'm only printing here that new has been called, and here I'm printing the type of the return value. And look at this. We are returning something here. Again, init initializes the instance, modifies its content, and does not return anything. But new returns a new object, okay? Let's use it. We create an instance, and you can see how new is called automatically, and then later init is called, okay? Let's call it, oh yeah, sorry, explanation. New is a special static method, but you don't have to declare it or define it as static because it's automatically done, okay? And it's called when you call the class. Look at this. What's the difference between calling this syntactically here? What's the difference between calling this and calling any other function? So, for instance, len. It looks the same, and actually it's the same. When you create an instance, you are executing the class. When you execute the class, new is called. The result of new is taken, and then init is called on that instance. Okay? And the strange thing here is that when calling new with supper, you have to provide here the class. In the previous examples with supper, you did not have to provide self always. But in the new, you have to do it. It's the only strange thing, okay? So, we can implement it. We can use multiple inheritance. We create an instance of this multiple inheritance class, and we see that our type is still our new type. Okay, verbose creator dig. But now we provided some arguments, and look, new is returning us those arguments. Well, it's printing them. So, what's receiving new? Let's go again to the implementation. New is receiving all the arguments of the initialization of the class, of the instance, of each instance, okay? So, if you want, you can capture it and you can check it and you can do some stuff. But look, it's not calling directly init. So for instance, what you could do here, you could check those arguments and implement a kind of factory pattern. And depending on the arguments, return an instance on another. It's up to you. Okay, let's see a better example. We can implement a singleton. How we implement a singleton? We store the new instance as a new attribute. If the attribute does not exist, we create it for the first time. And the rest of times, we return it directly. And this way, we have implemented a singleton. Do you understand it? Somebody said no there. Yeah. So, how it works? Let's use it. Okay. Python comes here and takes this statement and says, okay, I have to create a new instance. I take my singleton, I take the class, and I call new. New is called. The first time I arrive here, do you know what does this function? This function checks if an object has an attribute. So I check inside the class if the class has the attribute. The class does not have the attribute, does not have the unique instance that we're going to have. So we create it and we return it. What happens the next time, the second call? New is called again. We go here, we check, hey, we already have this attribute, so let's return it directly. And we are returning always the same instance. What's the problem of this implementation? What happens if I implement init, underscore underscore init, and inside underscore underscore init, I initialize some values inside the instance? Init would be called each time. So you have to be careful if you implement a singleton this way. Actually, the best way to implement a singleton in Python is just use a plain module and define there your attributes and define there your functions. And use it this way because it's easier than this implementation. Otherwise, if you implement a singleton this way, you have to be really careful in the underscore underscore init. Because, for instance, you initialize an attribute with value 0 each time that you retrieve a new instance, actually the same instance of the singleton, you would be changing it in the init. Because init is called anyways, if it exists. So you have to be careful. Okay? We can also, new is used to customize the creation of built-in types. It's not possible to declare, to customize the init, the underscore underscore init, when subclassing float, for instance. So you can do it in new. This is an ugly class, but well, it takes a float and it rounds the float to 2 decimals precision. Let's try it. The only way to do it is in the new, depending on which built-in type you are inheriting. And this is the usage of new. Factory pattern, singleton, customize certain built-in types. Yeah, this is it. Singleton pattern, also I would recommend you use a plain module, and that's all. Factory pattern, subclassing immutable types, certain. And also in custom metaclasses. What's a metaclass? Anybody knows the answer?
The creator of classes.
Yeah, that's it. A metaclass is the class of the class, or the type of your class, if you don't want to repeat class. But we have our dictionary, and its type is verbose creator dictionary. Fine. What's the type of the type? The type of the type is type. In other words, what's the class of the class? The class of the class is type. What does it mean? It means that when Python came here, when the interpreter had to read these statements, it created a class. The class is also an object inside Python. And you are able to customize which kind of object is it. So the first thing that I have to say here is that Tim Peters, I'm not sure if you know who is Tim Peters. It's one of, let's say, creators of Python or great contributors to Python. And he said that something like, if you don't know what are metaclasses, it's because maybe you don't need metaclasses. So today here, you are gonna at least try to understand what are they, but bear in mind that it's something really complex. It's like new. If up to now you have never used new, maybe it's because you have never. Most probably it's because you have never needed new. Okay, but let's implement a metaclass. Okay, well look, if you take verbose create director and we take its type directly, this is it. By default, the metaclass, so the type of all the classes is type, as we are seeing here, but you can customize it. This is a metaclass implementation. Okay, it just, again, it's called supper, so it does nothing besides printing a lot of stuff, printing all its arguments, okay? Yes, we only have new. As we have seen, new is called each time an instance is created, not initialized. Okay, so pay attention. We're going to see how a metaclass is used, but it's going to happen really, really fast. Why? Because look at this. The metaclass is used when the class is created. When it's created, the class, it's created in import time. Look at all these traces here. So the metaclass has already run. The new method has already been executed. When this console has taken all this piece of code and has interpreted it, it has created the class. And it's at that moment when the metaclass is taken and it's used. It's really important to understand this stuff. So it's exactly the same thing that we had with immutables defined as default values or as class attributes. They are created at import time, and this is at the same moment when the metaclass is used. And what can you do here? Let's look at the arguments of the metaclass. We received the metaclass. we received the name of the new class. We received the ancestors of the new class, here, object. And we received this dictionary. What's this dictionary? This dictionary is the content of the class. Its method, its class attributes. So, why do you want a meta class? What do you think that you could do here? You could, for instance, force that all your classes had certain attributes. You could add here in the dictionary. You could take the dictionary, modify it, or you could take the methods and decorate them if you want. So it's important to understand that the meta class acts is used in import time. Okay? So let's see an example and we will have finished. Now we can check the type of our meta class, and it's not type anymore. Now it's our meta class, okay?
I'm sorry to interrupt you. If we can finish in about 5 minutes. Or
Yeah, less. 1 minute. Well, no, one not, but.
Okay.
But so let's see a real example. Have you understood how it works in meta class? Any doubts? Any questions? Because this is the last example and we finish. So.
The usage of the variable underscore meta class, that's your choice? Or is it
No, it's how you have two ways to define the meta class. You can define inside a class attribute called underscore meta class, or you can define it system-wide with a global variable called meta class also, underscore meta class. So in my case, the way I most use meta classes is to apply decorators on demand. Instead of going to all the methods of my class and decorating all of them with the add symbol and putting the decorator, I can do it here in my meta class. Let's see an example. How many of you know or have implemented ever a decorator? Well, it's not our goal today, so you have to believe me that this is the implementation of a decorator. This is a method which can decorate attributes. And this is my meta class. Look here. Instead of creating the class with the original attributes dictionary, I call my method to decorate them. This method returns the same dictionary, but I look at it and each method I found inside it is decorated with my decorator. In this case, the decorator prints something if the result is not evaluated as true. Okay, and that's all. How I use it? Typically, I have a configuration somewhere, and I write in the configuration the name of the methods that they want, or the name of the classes that they want to decorate. And I only use it when in development, like testing. You can implement a decorator to do logging, to do timing, or this kind of things. And this way you can easily say, okay, I want to decorate exactly this method name and this method name. And I let my meta class decorate them. And I don't have to go to the module where they are defined and write the add decorator and this kind of stuff. I can save it and I do it here. It's really complex. I repeat what Tim Peters said. If you don't understand them, if you don't need it, most probably you wouldn't need it. Yeah. Well. So this is it. It works, and I have decorated automatically all the methods inside my class with this meta class. Okay. So to sum up really fast, with new you intercept the creation of instances. It's executed on instantiation time. when the instance is created, and it affects all the instances one by one. On the other hand, you have the meta class. With a meta class, you can intercept the creation of a class, of the class itself. So it's executed on import time, and it affects to all instances, but only at once. So if you change something in the meta class, you change forever for all the instances that you create of that class. And with this, I think that we can finish. So take a look at it, and I'll be here the whole week, and if you have more doubts, come and I'll be glad to answer your doubts. Sorry for the timing.
No, I think it was perfect.
Thank you.
Thanks to Pablo. Remember you all to vote his class, his training, because I think he should read the service on our mobile application. Lunch is as usual in the dining room of the hotel. And for every other question, you can find in your guidebook here that you was given in the bag. Okay? Thanks again, Pablo.
You're welcome. Hope you enjoy.